Iris. That song is amazing. One of the perks is you get to pick your walk-on music. And how many hip-hop concept albums do you know that drop a rhyme about MS-DOS? Like, one. Yeah, the answer is one, by the way. It's thought leadership. You got to give the answer. Good morning, everybody. Welcome to Keynote 2, the sequel. I don't have a snazzier name for that, but hopefully it's a good sequel. It's a more freewheeling, wild-ass sequel like Aliens or Terminator 2, and not a bad sequel, like Speed 2 or Too Fast, Too Furious, or all the Star Wars prequels? I don't know. Oh, I shouldn't have said that. That's probably out of everything I say, I'm probably going to get the most static about trashing the Star Wars prequels. Anyway, so how many of you were at the party last night? That's awesome. How many of you bowled? Enough. I want to talk to you later to tell me, how does bowling work? Like, is the strategy to just throw it as fast as you can? Because I don't think that works. I played pool. I did not bowl. I played pool with Ethan and Finch. And they assured me before we played that they were terrible pool players. And then we played, and they destroyed me. And I got hustled, but it's fine, because my children didn't need to go to college anyway. So it's great. It's great to be here. I'm glad you all made it, even though you look a little red-eyed. OK, so that's enough banter. Let's light this candle. According to the official laws of keynote speeches, which I just made up, it's incumbent upon you to talk a little bit about the present and the future. You have to do that. Otherwise, they fine you, or you get docked. But making proclamations about the future is really tricky, and I don't enjoy doing it because I don't really enjoy being wrong. And you expose yourself to great risk of being incorrect when you predict things. This is I love this picture. This is from a series by Maximilian Weimar done in 1910. And he was trying to conceptualize what things would be like in the year 2000. And this is great because it's someone feeding information into the machine. It's going through, I don't know, some Tesla stuff, I guess, into someone's dome piece. I think it was a simpler time. The it's not too far off if I think about it, right? It's kind of like the internet. Only, in 1910, they had these quaint ideas that people would be feeding in stuff like, it's math and history and philosophy and all this other cool stuff. It turned out now it's really just like, it's your misery and anxiety, and is the earth flat? Are sharks real? How do I topple an election? Like, it's too soon. But the one thing I think, so it's hard to make predictions, but the one thing I can feel confident about predicting is that, or making a statement about, is how complicated I think the world of technology actually is, and how it will become even more complicated. I love this picture. This is by Andreas Gursky. He does all these really kind of super wide-angle shots of a lot of stuff. And I think this is very emblematic of a lot of problems that I run into technologically, I think, in 2019. If you were in the systems building business, or the systems operating business, or the systems administering business, then there is this overabundance of choice that you have available to you in just about any facet of what you're trying to get done, right? There's tools, patterns, technologies, platforms, languages, frameworks, and it can be kind of overwhelming. Unless you think I am exaggerating, I encourage you for a moment to pause and try to think about how much difference there really is between something overwhelming like this and something like this, which is the CNCF landscape slide. We're right there, I think. So what do we do? How do you navigate these these really murky, complicated waters? Do you just kind of abandon everything to do with technology, and you put on a shawl collar sweater and you go out by the shore and you wait for the sweet and everlasting embrace of the Mother Ocean to just take you and wash all of your cares and fears away, like I want to? No. maybe another option would be to work really hard in the infrastructure world and eventually become chief technology officer of a software company, and you get to decide what you want to do to make this problem go away. So here's what I think. Here's my opinion. I think if you want to successfully deal with all of this insanity that exists in the world of technology, if I'm going to be running a company in this universe, the way in which I want to deal with it and the way I want to succeed is by doing three things. And I think we have to do these three things really well. Number one, we have to have outstanding power tools for people. They have to be things that let you do awesome stuff, but at the same time is accessible by the masses. I don't think my sense of taste is not one that prefers to build something that only a really small, narrowly, hyper-technologically sophisticated set of people can use. Because while that is indeed useful, I think it's more important to me and it's more meaningful to me to actually build something that's more consumable by absolutely the maximum number of people on planet Earth, because planet Earth has a lot of problems. I don't know if you were aware of that. I think number two, you have to have a really great ecosystem around all the tools. The tools by themselves are not enough. It is not sufficient. You need to have things that help make the tech more instantly useful to you with little or minimal effort. And you need to have a community around it that helps you actually go through the journey of adopting all of this stuff. There's no shortage of tools in the world. So which ones you pick, you have to kind of look at other adjacent sort of factors to figure out what really matters and what's going to solve your problem the best. And then the last thing, and perhaps most importantly, we need to do things in a way that helps meet you where you are and take you to where you need to be. It's easy to build tools in an island. Like you kind of build this silo where all these tools only work together if you happen to be inside of this silo. But in reality, I think the world is becoming increasingly mix and match, increasingly heterogeneous in terms of technology. And as Yvonne pointed out yesterday during yesterday's keynote, there's a spectrum of choices ranging from data center to containerization to using any number of what I assume is 12,000 different cloud services. Just wait till reInvent next month. There'll be like another 1,000 that I'm not going to understand. So in that kind of universe, what do you do if you're trying to make tools that are designed to solve a lot of kind of operational problems? Well, you could pick to optimize your tooling for people that live on just one far edge of that spectrum. Right? Or, my opinion is I think I would rather build tools that help you deal with the problems you have today, but can also give you enough of a path so that it's flexible enough so that you can take that and build upon those successes so that you can deal with the problems you're going to have tomorrow. So let's get into it. So first of all, tools. So what do I feel are the major kind of technological building blocks we have at our disposal? How many of you, is this the first Puppet conference you've been at? OK, so that's a lot. So you'll humor me. Those of you where it's not the first one, you'll humor me a little bit while I kind of outline sort of the core things that kind of make Puppet, the technology of Puppet, the technology of Puppet. So I'll start with desired state. Clearly, we are big fans of this. Spoiler alert. And I think I'm not going to dwell too much on this because I think you all probably understand it. But the whole point behind thinking about desired state is that it gives us these repeatable, safe abstractions for managing all kinds of systems, where you tell us what you want to have happen, and we'll kind of make it so. And we can do that around the clock, 24 hours a day, 7 days a week, all the time. You can safely do dry runs of everything, which is a unique property of desired state and our implementation of desired state. So that's pretty awesome. And like Alex mentioned yesterday, I think it's encouraging to see newer platforms and newer APIs start to adopt the desired state models as part of that's the way conceptually that their APIs work. Naturally, that's a really good fit for us. So this is awesome. We've been doing this for a long time, and thousands of you are using these features every day. So that's great. I like to keep on the art team. I like to think about desired state this way, where you tell Monet, I just want some haystacks. Dude, can you hook me up with some haystacks paintings? And that's all I want. The exact mechanism someone takes in order to render those haystacks is up to them. As long as I get the results that I want, it's OK to leave it a little unspecified. I express the desired state, and Monet meets the desired state. It looks a little blurry. Just kidding, that's an impressionism joke. Gotcha. I'm not saying that we are the Monet of infrastructure, but I did do a oil painting rendition of our logo, which I think looks super badass. And I did this by hand. Like, yeah. I used my hand to go to the menu in Photoshop and apply the oil painting filter. It was hard. You don't know what it was like. Art is a struggle, and the struggle is what matters. OK, so that's desired state. Tasks. So tasks is a newer primitive I think we've added kind of to the arsenal of capabilities that we have on offer. And this is because not everything can be handled by desired state. There are oftentimes things where just expressing the desired state is insufficient to represent all the steps that you need to do in order to actually achieve a result. So a few years ago, with the introduction of Bolt and more recent versions of Puppet Enterprise, we allowed people to augment all of the desired state stuff they're doing with the ability to do tasks. You can write these tasks in any language you want, from Bash to PowerShell to, I'm sure someone will do it in PostScript or something else awful. And they could be easily parameterized and shared and reused as much as you would like. And again, thousands of you are using this stuff every day, and that's also awesome. The version of this would be if I gave you step-by-step instructions on how to draw something. So you start at the beginning, and then you kind of follow step-by-step exactly what I tell you to do. And then at the end, voila, you have an adorable Snorlax, which, as we all know, has been scientifically and incontrovertibly demonstrated to be the best Pokemon out there. So you can fight me on it. Like, just come on, Snorlax. So once you have desired state and you have tasks, the next logical step is how you compose those two things together to get something done that's even more powerful. And that came with the introduction of plans. So a plan allows you to express in a single file, if you want, a handful of lines of code, the exact sort of workflow that represents what you're trying to get done. And that workflow can involve, at certain points, some desired state stuff, if that's the best way to model what you're trying to do, some imperative task, if that's the best way that you want to do it, along with some control flow, parallelism, error handling, all the things that you need in order to orchestrate all the crazy stuff that's out there today and all the increasingly complicated things that you are being called upon to do, right? So I think the metaphor here, plans are like Bob Ross, teaching you how to paint with his compassionate, calm, gentle demeanor, his infectious joy, and unironically amazing hair. The painting itself is a really interesting, complex workflow, if you think about it, right? Like, the order matters. Some things are desired state, like when he tells you to paint some happy trees on that side. It doesn't matter where exactly you put them or how tall they are. You have a little bit of latitude in order to do it. But in order to make the painting work, they kind of need to be in this particular area. That's the desired state. But some things are imperative tasks, like when he tells you to mix up a certain color. You take this much Havana brown, this much cerulean blue, and then I just realized if you mix those, you just get more brown, so maybe don't listen to me, because I don't know what I'm doing when it comes to painting. But hopefully you get the point. I think, if you, by being able to combine all these things together, you can make something at a higher level than if you just had those individual parts. And I think that's kind of awesome. If you haven't checked it out, you should check out, like, Twitch Watches Bob Ross, because it's amazing. It's also the internet, so sometimes it's not amazing, but Agents and agentless. So agents, which was the initial kind of architecture for Puppet, is great for solving a ton of different problems. It's great for safety. It's great for unattended around-the-clock operation of things. And having that persistent communications fabric between kind of the central systems in a Puppet infrastructure and all the endpoints where our IP is running, that makes talking to a huge number of systems at the same time fast and simultaneously pretty secure. Agentless is sort of a complementary approach on the other end of the continuum, which is you can achieve a lot of those same results, but it's perhaps a better option if you're trying to optimize for minimal setup and footprint, or you really care mostly about low-touch management of remote targets. And some targets you can only talk to remotely, right? Like maybe it's a device that you can't run something on, or it's an API. You can't run an agent on an API, right? So having an answer for both of those things, I think, is also really powerful, because there's no one size does not fit all, right? And we try to offer all of these primitives and packages that work for the masses. So that's why we support all the different kinds of targets, operating systems, architectures, platforms that we do. Because we want to make sure that everything we build has the maximum applicability, maximum suitability, and it can meet you where you are, right? And you don't have to be an expert to use any of these things. You don't have to have a PhD in computer science. You don't need to be able to reverse a linked list on a whiteboard with people watching and judging you with their Sauron-like eyes. You don't need to do any of that. This stuff is immediately accessible and usable to just solve your problems that you're actually having today with real-world stuff, right? And this is really important to me because I think it's really easy sometimes to get lost in what people are telling you should be worried about. Like it's very easy, I think, to listen to, go on Twitter and listen to people that don't build or operate things to telling you how you should build and operate things. But my belief is that what you already run, what you already know, what wisdom you've already gathered over your career, that stuff is precious and valuable. And I want to work with that. I don't want to replace it. And I think that's an important statement because not every tool is built, I think, on that kind of value, right? I do not view you all as things that can be replaced by scripts, right? You are not a Roomba, like as I think Luke said a couple of years ago. I do not want to turn you into a Roomba. I want to build you an Iron Man suit. So the actual tools themselves. So Puppet is a great power tool. You may have heard of it. It's kind of a thing. And it brings a lot of those capabilities I mentioned into a package that thousands and thousands of people use all the time. So last year we released Puppet 6, and I want to give a shout out to all the many, many thousands of people that are using that and giving us feedback, which is great. Some of the newer things we've been working on in relation to Puppet, Ethan and Morgan gave a talk yesterday, I believe, on Pupperware, which is a new project around actually containerizing the Puppet stack, both the open source stack as well as the Puppet Enterprise one. Many of you all have been asking for this. Our containers for Puppet services have been pulled millions of times off of Docker Hub. And it's awesome. If you haven't checked it out, you definitely should. It makes it really easy to get a Puppet stack going. And it works in pretty short order. You can get stuff going with a single command. And I would also love to give the community a big shout out on this one for adding support for Helm. They added Helm chart support as well as raw Kubernetes data type support for this. So that's great. There's also a talk later today on Puppet Server being containerized, so check that one out as well. Bolt is one of our newer power tools where we took Puppet and tasks and plans, and we put them all together and wrapped it in an agentless, easy-to-use tool that you can get started with in seconds. So if you're an open source user of Puppet, this is great because you can easily apply all of your Puppet code remotely onto all of your new systems. And it's also cool from a content point of view because you can combine you can augment your existing Puppet modules that do desired state stuff with imperative tasks to make them work better, to add things that automate stuff that you might need to do on a daily basis. Quiesce a system, flush a queue, restart something, all the things that you normally would need to do can now be encapsulated inside of the same module that you can share on the Forge like you've always been used to. And if you're a Puppet Enterprise user, Bolt is really good for you too because you can do everything I just said, but you could do it with lower latency and with a higher degree of parallelism because of the communications fabric we have inside of that. So if you haven't checked it out, you definitely should. Our newest power tool, I guess that's sort of on the, I was going to say maybe most bleeding edge, but power tool, bleeding edge, like you don't want blood and tools in the same metaphor. It's weird. Our newest one is a project we released recently called Wash, which is the wide area shell. So Wash tries to take some of the same lessons that we've learned with Puppet and Bolt in terms of building abstractions for complex things and dealing with remote connectivity and remote APIs. And how do we apply that to a new problem, where that problem is there are lots of tools out there to help you provision and configure systems and configure modern cloud infrastructure. But where are all the tools that help you deal with them interactively, right? Because this stuff doesn't manage itself. Where are all the things that helps you easily in a uniform way, no matter where your stuff is running, do things like running commands, getting log output, listing what you have? Every single vendor has different siloed tools that lets you accomplish all of these tasks. So what if we applied the same philosophies we had inside of Puppet that intended to abstract these things to make it simpler for you and applied it to modern infrastructure, cloud native infrastructure? How would that look? So if you haven't tried it yet, you should definitely check it out and kind of test it out. And then I don't know if Michael Smith is in the audience, but he's running one of the booths downstairs where you can actually see it being demoed, which is awesome. And I'd also give another shout out to the community. Thanks for adding Kubernetes context support just last week. That was really awesome, so thank you very much. So we could talk about tools all day, and we have a, we could make an entire conference, I think, just about tools if we really wanted to, but tools are not enough. They need a really vibrant ecosystem to kind of amplify how powerful that stuff is. And so many of you contribute to the ecosystem in so many ways, just hanging out on Slack, helping people if they have problems, and just generally creating a really friendly and welcoming place for people that engage as part of the Puppet community. And also, you have written so much code, like a lot of code. Thousands of you are interacting with the Forge all the time. There are hundreds of millions of downloads of different Forge modules, and you're constantly hitting like all the Forge APIs. 3 out of every 4 commits that come into a repo as part of the Puppet Labs organization on GitHub come from someone in the community. So that's awesome. So that right there should signal like there's really no way that we can do what we do as effectively as we do it without help from everyone, without help from all of you. So this is why we care about making content development as pleasant and easy as possible. This is why we build things like the Visual Studio Code extension for Puppet, which is amazing. You have smart completion, you have documentation lookup, you have outlining, breadcrumb symbol support. This is amazing. There's like tens of thousands of people that have actually downloaded it and uses it. So drink the Kool-Aid, express regret for the VI or Emacs tattoo that you got, and then download VS Code and start using this. I actually have a notepad.exe tattoo across my back in Times New Roman, Tahoma, The VS Code extension integrates really nicely with the PDK, the Puppet Developer Kit, which makes linting and releasing and building your modules really simple and straightforward. And new projects like Litmus make acceptance testing all of your Puppet code so much easier. You should definitely check that out. And if you want to hear more about Litmus, you should listen to TP Honey's talk that's going to be happening later today on Litmus and PDK. So definitely go and check that one out. He's really awesome, and he built something really great here along with the community's help. And also, he has an accent that makes everything he says sound smarter. So I'm really proud of the Puppet ecosystem and the community that we have here. I think there's a lot of really good utilities, frameworks, and development environments available, and there are a lot of folks out there using them to build all kinds of awesome stuff and sharing that stuff with the world millions of times over. So I give us a thumbs up on that one. Bing. Which brings us to the last item. This is a photo from the set of Cosmos. That's Carl Sagan in 1980, done by ABC. Carl Sagan famously said, if you want to make an apple pie, you must first invent the universe, right? Which is technically correct, the best kind of correct. And yet, but that's not super practical, right? And yet, so many companies and open source projects take this point of view with their technology and with all of their tools. You have to live entirely within a universe of that tool's construction. Conveniently of their own construction, only solving problems that those sets of tools say are important, and only solving them in the way that they say is OK for you to solve them. But me, I do not want to build the universe. I'd rather just give you the pie. One of our core values, I think, has always been to really meet you where you are. If you have stuff written, I want to wrap it, not necessarily make you rewrite it, because I believe it's better for you to have a running start than to force you to have to start from scratch. And I think that's what makes us different. You don't have to completely rethink or re-architect how you do anything in order to start taking advantage of tools that help you automate and eliminate the most soul-crushing work that you have to do. And new applications are created faster at this point than old ones are decommissioned. Right? It's really easy to build new applications now. So if you do the math, just think about that for a second. If you do the math, that means on a long enough timeline, which isn't that long, you are going to have an increasingly heterogeneous mix of tools, of technologies, of patterns that you've used to make all kinds of different things. Every tick of the clock. So the tools you use need to be able to address all of that stuff. And that's always been our sweet spot. We listen to the things you tell us you need, and then we integrate with that, because we've never needed to own the whole stack. In the very beginning, you would tell us that you needed us to integrate with operating system native package management, like RPM or MSIs or something. And we didn't say, no, we're going to invent our own package manager. Instead, we said, of course, we will just integrate with that, because that helps you solve your problem, right? We don't need to own the entire stack. More recently, you would say, we already have a bunch of scripts that help us get X, Y, or Z done. Can you help us? And then rather than make you rewrite it, we can come up with something like the task abstraction inside of Bolt, which helps you wrap that, parameterize it, make it more reusable. Instead of forcing you to rewrite it, that's a running start. That's good. And now you're telling us that you're using tools like Terraform to provision cloud infrastructure, and you would like us to integrate with that as well. Of course, I think that makes sense the same way all of these other things really make sense. So to talk a little bit more about Puppet, Bolt, tasks, Terraform, and generally meeting you where you are, I would love to welcome to the stage probably the subject matter expert on all these things and the best sneakers in the business, Yasmin.
Thanks, Deepak. I'm really excited to be here. It feels like just yesterday we were in Puppetize Live Sydney announcing Bolt's 1.0. It's crazy to see how far we've come in the last year, and we even have this awesome new logo now. I think you summed it up nicely, though it took a little bit, and there was a lot of references to things I didn't totally understand, but we've been spending a lot of time meeting our users where they are and taking them where they need to be in both the product and in the real world. Just this week, I was talking to a Bolt user who went to a workshop and brought Bolt back to his Windows team and got them automating in a way that he couldn't do before. And it's stories like that that make me really proud of all the work the team's done to meet our users where they are in both the product and in the community. For example, we recently made the move to GitHub for everything. We've obviously already been doing our development there, but we wanted to make one less place for you all to go. We know you don't like interacting with Jira. It's kind of annoying to track the tickets there. So we moved to GitHub for our planning, our tracking, and all of our development. And we've been pretty busy. In the last year, we've had over 30 releases of Bolt and merged over 400 pull requests, which is pretty amazing. Also, we've been stalking you. You may have noticed Bolt popping up at different events, or maybe you've seen one too many Twitter ads, but we've been pretty busy. And all around the world, we've had over 25 Bolt workshops from London to Singapore to right here in Portland. And these workshops have been a fun way to either get you started with automation or help you expand it throughout your organization. And you've all given us feedback that the workshops are not only good for learning Bolt, but taking it and applying it to problems in your organization. And we're happy to help with that. We've also maintained our focus in meeting you where you are in terms of the languages you prefer to use for automation, or reusing all the Puppet code you spent so much time building up. Or dare I say it, YAML plans for all of you YAML engineers in the room. And it turns out we're not the only tool you use, so we're making it easier to integrate and plug into your existing workflows. We've built integrations with AWS, Azure, PuppetDB, and Terraform to dynamically discover your infrastructure and help you manage it. And we've taken those integrations beyond just the inventory. We're making it easier to manage and securely store your sensitive data as well with plugins with YAML and HashiCorp's Vault. The best part of these plugins is that they're written on a common framework so they can be reused and shared on the Forge. You can customize them for your organization, and they're written in any language, so they're really easy to get started with. I'm most excited about the beginnings of a Terraform integration because Terraform's pretty good at provisioning infrastructure, and Bolt's really good at making that infrastructure do real work. And you've all been asking us for a way to use the two tools together, and that's what we've been working on. So I have a demo here, and I've already actually provisioned some targets with Terraform. I'll just go through that quickly. You don't want to see all that. I promise you, they're provisioned. With Bolt's V2 inventory, I can use the Terraform plugin to discover all of my targets from my Terraform state file. This is cool because I don't have to actually know the IPs, and I can reference the source of truth directly. I'll go ahead and just run a command using Bolt against those new targets. For now, I'll just tail some log files. And then I can target my group. Quickly, I got back some log files, which is cool, but in my previous life, I used to be a Splunk admin, so naturally when I see log files, I just want to send them to Splunk. And lucky for me, I have a Bolt plan that does just that. So Bolt plans allow you to orchestrate tasks, commands, or Puppet code across your infrastructure. This plan specifically sets up a Splunk surge head and then installs forwarders on all of the targets I pulled in from Terraform. The Bolt apply function allows me to embed Puppet code and compiles it locally so I can reuse all the content from the Forge. And shout out to Vox for maintaining the Splunk module, because I can promise you it's so much easier to use this and write it from scratch. So I'll go ahead and run that Bolt plan. And I have confidence that Bolt's going to run each step in the right order. As this finishes up, I can open up Splunk, and I should start to see my data. Yes, I know I have a lot of tabs open. This is on a good day, too. So I can start searching for my data and use Splunk to set up alerts to let me know if the CPU is too high or maybe the file system's full. But what's really cool is we have a Puppet add-on that allows you to create alerts that run Bolt tasks. So I can create an action that maybe clears out my file system. And that's super easy to do. This is something I really wish I had in my previous life, because Splunk obviously makes it so easy to find things, but Bolt makes it so easy to actually go out and fix them. And using the two together is so powerful. I just want to take a second to talk about what we did, because it went by really fast, because Bolt really is that fast. Because I have Bolt on my laptop, I can get started quickly and automate everything I need right from my workstation. But if I want to scale this out, everything I just did is completely reusable in Puppet Enterprise as I want to enforce my state at scale. I'm really excited to see you all use this, and let me know how you like it. I'll be around all day. You can come find me, and I really hope you try this out. I'd love to pass it back to Deepak. I'm sure he's going to. I forgot to swipe.
OK. Thank you, Yasmin. I think that example was awesome. I think we unintentionally ended up with like a naming theme around like everything relating to the cloud as being like celestial. You've got like Bolt, you got Nebula. So, you know, yeah, I don't know what that is. Carl Sagan, everybody likes space. To talk a little bit more, so, you know, I guess while we're on the theme, yesterday we mentioned Nebula, which, you know, I'm super proud of, because I think it's a pretty user-friendly take on how to harness, you know, how to kind of wrap your arms around all the complexity that I would argue is, at least currently, pretty inherent in doing a lot of cloud-native stuff. And yesterday, you know, Melissa was on stage and showed you how Nebula makes it really easy to build and share workflows that streamline a lot of this stuff. And she mentioned briefly that under the hood, Nebula makes use of an open source tool that's part of the Continuous Delivery Foundation called Tekton. We're one of the founding members of the Continuous Delivery Foundation, and you know, I believe in the mission of trying to come up with a vendor-neutral home for all these open source projects that kind of aid with continuous delivery. So to talk a little bit more about Tekton, I would love to welcome to the stage one of the people that works on Tekton from Google, Scott Seaward.
Thank you very much. All right. Thanks very much, Deepak. That was a great intro. Hi. As Deepak mentioned, my name is Scott Seaward. I'm a software engineer at Google, and I work on Tekton. And today, I'm going to talk a little bit about Tekton. I'm going to talk about the aims of the project. I'm going to describe the specification and the implementation that Tekton introduces. I'm going to talk a bit about the history of the project, talk a bit about the CDF, and finally, I'm going to end just with some of the kind of future features that we're hoping to introduce with Tekton. OK, so where should we start? Let's start with the elevator pitch. The elevator pitch for Tekton is that it is a platform for cloud-native CI/CD. OK, so that's good as an elevator pitch goes. But what I'd like to do is try and break that down a little bit and answer the question, what is Tekton really? In order to do that, I think we should start with kind of defining what we're talking about when we talk about CI/CD. So for the purposes of this talk, CI/CD is kind of an ecosystem of tools that you use to build, test, deploy, integrate your code or the code of the teams in your organization. Now, if you were to take a broad cross-section of many of the CI/CD tools in the open source landscape, you would start to find common patterns across many of them. You would start to observe that many of these tools implement their own workflow or pipeline engine. And typically, the way that this is implemented is that they will have a concept of a kind of a task, which may then break down into a linear series of steps. And those tasks are orchestrated or organized into a pipeline, which is typically modeled as a graph, a directed acyclic graph. And it's kind of this platform, this kind of workflow engine that Tekton aims to provide. We want to provide a cohesive base for other CI/CD tools to build upon. Now, many of these tools, if they're built on Kubernetes, will be using the Docker container as an abstraction for that individual step or that individual task. OK, so Tekton is a platform for other CI/CD tools to build upon. But what is it that Tekton kind of provides? Or what is the problem that we're trying to solve here? Well, if all of these tools are building their own workflow abstraction, their own kind of pipeline abstraction, then we miss an opportunity for those tools to integrate with one another because they're not speaking a common language, a lingua franca. OK, so how do we actually achieve this with Tekton? So the first thing that Tekton introduces are a set of specifications for components that are reusable by CI/CD tools. We introduce first the task, which we've already described, which breaks down to a linear series of steps. And in Tekton, each step is modeled as a Docker container. And then we introduce a pipeline. And a pipeline is that graph of tasks. So that's good. We've defined the pipeline and the task. But we also need to define a specification for the execution of those tasks and the execution of those pipelines. And for that, Tekton introduces two more specs. These are the pipeline run and the task run. But there's still one thing missing. We want to be able to model the assets or resources that your pipeline needs in order to execute. And for this, we introduce a pipeline resource spec. And the pipeline resource is really intended to model any meaningful asset that your CI/CD process needs. So why do we specify these things? Well, going back to the original problem statement, there is an opportunity here for tools to communicate with one another. And it might be simply that they can read each other's state. It might be that they, in some future, are able to share work in some way. But we want to be able to provide that common base for them all to use. OK, so that's good as far as it goes. We've specified a set of objects that are common to many CI/CD tools. But there is more that we can do here. We can actually provide a platform that other tools can use today to build upon. And so that's the next thing that Tekton introduces. It provides a Kubernetes native implementation of these specs. And what do I mean when I say that it's Kubernetes native? I mean that it runs as a controller in your Kubernetes cluster. And when you submit a task or a pipeline, the controller processes that. And when you submit a task run or a pipeline run, the controller actually actuates or executes work based on the objects that you've submitted. Now, I don't want to get into too many of the details here, but I do want to describe a little bit about how this kind of shakes out in terms of Kubernetes resources. So when you submit a task or a pipeline, the first thing that Tekton does, the controller does, is it simply validates that the task is formatted correctly. It validates it against the specifications. Then when you want to actually execute a task, you submit a task run object. Remember, this is runtime information. So this might include things like the specific Git repo that you want to process, to actually build from. It might include references to specific files that you need in a cloud bucket. And so when you submit that task run, Tekton creates a Kubernetes pod. And for each step in the task, a container is added to that pod. Now, some of you might be aware that when you start a pod in Kubernetes, all of the containers inside that pod start executing at the same time. But remember, what we want is a linear series of steps to be executed one after the other. And so Tekton has to introduce some work here to sequence those containers. And what we do is we mount a volume for each of those containers, and as one step executes, and when it completes, it writes a file to that volume that the next step is waiting for. And so on. The next step does the same thing when it completes. It writes a file, and the third step continues from that point. And in this way, we're able to sequence the containers inside of a task. And that's valuable because this is the kind of bookkeeping that your tool, any CI/CD tool, should not have to re-implement every single time. And so this is the kind of value that Tekton provides. OK, so let's recap. The aim for Tekton is to provide a cohesive base for CI/CD tools to build upon. We do this by specifying a set of common components that we see across many CI/CD tools. And finally, we provide a production-ready Kubernetes native implementation of those specs so that tools can start building on Tekton today. OK, next, I'd like to talk a bit about the history of the project. I'd like to talk a little bit about the CDF and the community, and I'd like to end with just where the project might be going next. OK, so Tekton grew out of two prior projects, the first of which was intended to build containers for serverless platforms, the second of which was intended to sequence tasks in a CI/CD pipeline. Tekton was released to the public in August 2018, and about 6 months later was donated to the CDF. The CDF is an organization composed of many member companies, of which Puppet is one, and it owns these 4 technical projects: Jenkins, JenkinsX, Spinnaker, and Tekton. Now, one of the aims of Tekton is to remain agnostic to any specific tool that is built upon it. More concretely, what I mean is that there should be really no code paths in Tekton that are specific to a single tool or a single product. And it's in that context, I think, that it makes sense that it's owned by an organization like the CDF. There are many member companies. Some of them may compete with each other, and some may simply be end users of its technical projects. But together, they have kind of a vested interest in raising the bar for CI/CD. OK, so speaking of the CDF and its members and of Tekton, let's talk a bit about the community. So this is the only wall of text slide in this presentation. Apologies for that. But I wanted to highlight that companies today are deriving value from Tekton. We have a repository called Tekton Friends, where companies can self-identify. They can describe how they're using or how they're contributing to Tekton. And this is good for us for 2 reasons. The first is that it provides a strong signal to us that Tekton is being used, it's being exercised, which is great, and it helps to set direction. But also, the second thing is that it provides a strong signal to people who aren't using Tekton yet that you can use this today. And in fact, I should mention at this point that Tekton is still in alpha, which, in a sense, for me, is even more validating. The project is still quite nascent, it's still quite new, but people are already deriving considerable value from the work that we've done on it, which is incredibly validating. OK, so now we've talked a bit about the community. I'd like to talk a bit about where the project is going next. As I mentioned, we're in alpha. There's still considerable amounts of development going on. And I think it would be disingenuous for me to stand here and tell you that I can tell you exactly where the project is going to go, because there is simply too much work going in for me to summarize exactly. I think I would also waste a lot of your time if I did that. So instead, what I've done is I've chosen just kind of 5 of the highlights, the kind of product highlights that I see that are important for the next few months of Tekton's development. So the first of these is Tekton Triggers. Tekton Triggers aims to provide similar specification and implementation details that Tekton Pipelines provides for pipelines, but we want to do it for the process of triggering CI/CD processes. So some of you, many of you, I expect, may have set up kind of webhooks or endpoints so that starting pushing a branch, creating a pull request will start a CI process. It will start a suite of tests, perhaps, start integration processes, linting, these kinds of things. And these are the kinds of processes where signals are coming from outside external systems into your CI/CD system. And this is what we want to be able to model with Tekton triggers. OK, so that signal is going into the CI/CD system. We also want to be able to model signals coming out of the CI/CD system. This, I mean, you may want to, for example, send an email when a pipeline fails. You may want to send a Slack message to your developer channel when a long string of failing pipelines is followed by a successful one. These are the kinds of things that you should be able to model with Tekton notifications. Next, we've got the observability track. For those developers who are building on top of Tekton, it is vitally important that they can see into how the system is operating. You should be able to tell where there are bottlenecks. You should be able to tell which pipelines are running the most and how long they're taking. On top of that, we'd also like to provide traceability so that tools running on Tekton are able to debug efficiently. Extensible resources is something that I have very close to my heart. I'm currently working on this closely. It's the pipeline resources that I described earlier. At the moment, there are a very limited set of them. So for example, we model Git repositories and Docker image registries and files and directories in cloud buckets. But what we want to be able to do is allow you to model any asset or anything that your organization needs for its pipelines. For example, you may have a specific file format that you need when you're performing a deployment. That should be a thing that you can model using pipeline resources. And so there's a lot of work going on right now to try and design them in such a way that they can provide that. Finally, we're going to beta. So this will involve deciding specifically which APIs are going to be promoted from alpha to beta, and also providing support around those APIs, deciding how they're going to be stabilized, and finally deciding the deprecation policy for the future if those APIs ever do need to change. Luckily, a lot of work has already gone into play for this, and we are expecting, right now, who knows what happens in the future, but right now we're expecting to go to beta either December of this year or January of next. OK. Thank you very much for bearing with me so far. Go to github.com/tektoncd/community to find out more about the project. Join our Slack group. Come and ask questions. You're very welcome. And thank you very much for listening. And I think at this point, I'm going to introduce Eric up on the stage to do a little demo of Nebula. Thank you.
Everybody, you awake? Good. Hey, I'm Eric Sorenson. I've been at Puppet for a long time. I've been here for over 7 years now and was a community member for several years before that. For almost the entire time that I've been at Puppet, I've been working on Puppet itself. And lots has changed in the world since then. There's the rise of cloud computing, containerization. Docker didn't exist when I started at Puppet, and now it's everywhere. So when I got the opportunity earlier this year to start in on working on a new project, I found myself with a strange mixture of excitement and fear. I was excited because all this technology is really interesting, and while I dabbled and touched on some of it in the intervening few years, I hadn't really had a chance to dig in deeply. The fear part, though, was, what if I couldn't figure it out? What if things had moved too fast? What if my skills and the things that I knew were hopelessly mired in the past? I'd be like the punchline of an old man yells at cloud joke. Turns out that it's not that much different. Software is still the same. Those skills still work, even in new contexts. And infrastructure is still mostly terrible. If anything, the tension between visible complexity and additional layers of abstraction and navigating those waters is even more important now because of how many additional layers there are. I found it challenging and fun to dive into this world of cloud-native infrastructure. My job today is primarily as a liaison between the internal Puppet teams and the upstream communities like the CDF that we're working with. I want to help Nebula move faster by incorporating some of the platform features that are available in Tekton that Scott just talked through. And I want to help the upstream projects by pointing our design, product, and development resources at projects that can help everybody that make use of the features that can help everybody that makes use of the platform. So today, I want to go a little bit deeper and show you how Nebula uses Tekton and Kubernetes. Scott mentioned that Tekton evolved from the Kubernetes-based build and test system, and we learned about Tekton at KubeCon when Christy Wilson on the project demoed it for us. It was kind of a light bulb moment because it seemed like we could drop in the Tekton capabilities in place of in-house code that had already been written and accelerate the project pretty dramatically. It could go underneath the GUI that we'd built, the public-facing API, and the workflow language that provide a little higher order of abstraction than what the raw Tekton CRDs provide. But because Nebula was already being written as a Kubernetes native application, we were able to wire it up very quickly, get a proof of concept going, and that's what we're shipping. So how does it work? Following that hierarchy of terms that Scott explained, I'd like to walk through a simple workflow and show you how Tekton makes use, or how Nebula makes use of Tekton and Kubernetes under the hood. Just a minute to get set up here. All right. So I have a Nebula instance that's running on GKE. I've got both the Nebula front end as well as the Tekton dashboard installed. The Tekton dashboard is an open source project that the community is working on that shows the internals of Tekton. So we'll walk through the workflow and how those things work together. On the front end, Nebula handles things like the authentication, access control, the visualizations. Yesterday, Melissa showed a really complex bike shop application which shows the power of the Nebula workflow language and what you can do with the interface. I have a very simple workflow that does two things. It first runs an Alpine container that just says kind of a hello world, and then it'll send a Slack notification. The workflow is written in YAML because YAML is how you know it's cloud native. The steps can be either generic containers like the Alpine one, or they can be purpose-built for Nebula. This one has the Nebula file system laid out on it and some command line tools that help the container introspect what's going on inside the pipeline and pull environment variables out of the Nebula run. We have a number of steps already built, and it's really easy to make new ones. There's steps that run things like Canico for building container images, Terraform for provisioning, and Helm for application deployments. That higher order of workflow abstraction also has handling for secrets, which we integrate with HashiCorp Vault and keep the secrets in there so you don't give away the keys to the kingdom, or in this case, to the Slack API. When I run this workflow, I just need to feed it a channel to post to and give it a message. We'll say hello from Puppetize PDX. This kicks off the run, and as it's going, you get a real-time update of how the steps are proceeding. And you can see in the Nebula UI what happened during each step. I'll flip over to the Tekton dashboard, which again provides a little bit of a lower level of visibility into what's happening across the Kubernetes cluster. Nebula is translating each of those steps into the Tekton objects that Scott just walked us through, and is creating a new namespace on the Kubernetes cluster that shows up here in the UI. Nebula handles things like the access control for those namespaces so that one team can't go in and see the results or the output of another team's workloads if they're not allowed to. Again, this is the kind of raw objects that are created on the Kubernetes cluster, and we can see that the tasks the task run completed successfully. And these are the raw Kubernetes objects that were created as a result of having launched that Nebula run. And you can see that they ran successfully. And when I click over to the Slack notification, we can see we got a notification and some cute pugs. So just a short demo, but that's how those things work together. Tekton provides some really important platform capabilities that we're trying to make use of in the product, and we want to continue to help out the development and take advantage of some of those forward-facing roadmap features like Scott was talking about. The prospect of being able to gate the execution of a pipeline based on an approval or an external notification coming in is really an important capability that's going to come up. And it's awesome to have Tekton handle all of those nitty-gritty details about pod execution, parallelism, error handling, and let Nebula build those higher order abstractions that let you make workflows that you can share across your teams. So we're still at pretty early days with this, and I'm pretty excited because our roadmap is pretty closely aligned with where Tekton is going, and we're looking forward to, as the saying goes, chopping wood and carrying water, doing that unglamorous but necessary work in order to help the project along, fixing bugs and improving the state of those upstream projects as well as the product that we're shipping to everybody. In a sense, this represents a bit of a philosophical shift for us at Puppet. We've traditionally worked in open source in single vendor ecosystems that we sort of built ourselves and people joined onto. But there's been a huge shift in the way open source happens out in the wider world. And this move to multi-vendor ecosystems, to foundations like the CDF is a big part of that. And so we're shifting our approach as well. We're starting to look at our projects as possible components for upstream projects rather than being an end-to-end workflow in its own right. That's how the Lyra project evolved from being a Terraform-esque workflow engine to being components like a Go implementation of Hyra, a simple type system that can be integrated against other upstream projects, and we can inject some Puppet DNA into these upstreams and get good usage as well as help those upstream projects with problems that we have expertise in managing. We have a decade of experience in managing complexity, and the lessons that we've learned from managing infrastructure, from building power tools, and helping teams are even more widely useful now than they used to be, because the complexity is no longer concentrated in the largest companies and the most sophisticated infrastructure. It's distributed everywhere, and so we're really looking forward to helping out with those problems across the wider ecosystem. Thanks a lot. I'll bring Deepak back up.
Oh, I love that so much. Trash the whole computer system and revert you to papyrus. It's a real line. It's a good rhyme. So thank you all. This is the end of the keynote. I know we have poured a lot of good stuff into your brain holes. And it's a pretty broad spectrum, but I hope we've tried to really demonstrate and show you things that A, are real, B, you can use, like right now, and C, represent kind of the breadth of the entire continuum of things and the different kinds of problems we want to help you solve, the different approaches we're trying to take to help you solve them, but also trying to share with you, I hope this gives you a better understanding of what our technological kind of sense of taste is and the kind of common things and the common values and the common primitives and patterns we want to apply to help you solve those problems in a way that's kind of consistent and fits into your brain hole. But if there's still room in your brain holes, do not worry, because there are still a ton of awesome sessions left later today. And you should definitely go and check all of those out. And I will find you in the hallway afterwards, and I will quiz you on what you liked about them. And you can fight with me about what the actual best Pokemon is. So other than that, I just wanted to say thanks to everybody. I have a few quick closing messages. I did want to give a shout out to all of our to the sponsors. And our unofficial sponsor apparently, which is YAML, the markup language that we have only ourselves to blame for. For those who are interested, I definitely encourage you to join the women and non-binary folks table during lunch in the exhibit hall. And other than that, that is it. Thank you for coming, and please enjoy the rest of the show. Thank you very much.